All right. Point 55 now, because people are saying, teacher, these exercises have fractionaries and we don't know how to work with them. So can you guide us? Absolutely. Absolutely. So in this case, look, we have a fractionary as the coefficient of x, a fractionary as the coefficient of, I'm sorry, a coefficient of x squared, and then a fractionary as a coefficient of x, and then another fractionary as the constant value. So in this case, the values of a, b, and c are going to be fractionaries. Let me write a, b, and c. The value of a will be the coefficient of x squared. So this is the fractionary 3 over 4. The value of b is going to be the coefficient of x. So negative 1 over 4. Don't forget about the negative. And the coefficient of c, the value of c is going to be the constant value, the one that doesn't have a variable. So negative 1 over 2, negative 1 half. And now that we have those values, all we have to do is replace in our quadratic formula. So I'm just going to replace it here. I am not going to write the quadratic formula again. I feel like by now you guys have an idea of what is the quadratic formula. So the quadratic formula is a big fractionary, and on top we have negative b. So negative 1/4. Negative 1/4. There we go. Did you see? Maybe this cannot be seen. All right, let's see. Negative 4. Better? Beautiful. Let's continue. We have a plus minus the square root of. And inside of the root, we have a lot of numbers. We have b squared. So we have negative 1/4 to the 2 minus 4 times the value of a, which is 3/4, times the value of c, which is negative 1/2. There we go. That was the numerator. Now let's go with the denominator. In the denominator, we have 2 times a, and the value of a will be 3 over 4. There we go. So look at this. All I'm doing is replacing the values just like we did in previous exercises. The only thing that is different now is that these exercises have fractionaries. So how do you work with fractionaries? Okay, you can do that. You can do that by using the properties of fractionaries. All right? So let's begin. Let's do this step by step, just like we did with the previous exercises. Okay, so we have negative and negative. This will give us so that the positive value will be now in the 1 over 4. Negative and negative will give us positive. So we have 1/4 positive. Then plus or minus, and now we have a square root. But the square root of what? Okay, let's work it little by little. What is the square root of 1 over 4? In case you don't remember, this square root goes and applies to both up and down, on top and under. It applies to both numerator and denominator. All right. So we have negative 1 squared. Don't forget about the negative. It doesn't just apply to the 1. No, it applies also to the sign. So we have negative 1 squared, which is positive 1. And 4 squared. 4 squared will be 16. So I'm going to write it here. 16. Let's continue. Minus 4 times 3 over 4 minus 1. Okay. So how do we multiply this? Okay, in case you forgot, the way you multiply this is by making this 4 a fractionary. And you're going to make this 4 a fractionary by putting a 1 under it. So now the 4 is the fractionary 4 over 1. And now that we have two fractionaries, we can multiply these directly. 4 times 3 and 1 times 4. 4 times 3 will be 12, and 1 times 4 will be 4. So we have 12 over 4. Did you see what I did? But look at this. Since the 4 is multiplying and the other 4 is also dividing, we have the same value multiplying and dividing. We can cancel those two. So what we have here is just 3 over 1 multiplied by negative 1 over 2. Did you see? If I did the multiplication in the longer way, 4 over 1 times 3 over 4 If we did the multiplication in the longer way without doing this cancellation, we would have 12 over 4. And we can simplify that 12 over 4. We can simplify. We can take 4 on top and 4 down. This will be 3 over 1, which is exactly my value. So this cancellation avoid me from having to do this longer multiplication, just because I could cancel. Now, that cancellation cannot always be done. It can be done only if the number on top and down in the denominator, these are the same. If they are not, then you cannot. Also, the number have to be both multiplying and dividing. If on top is addition and down is a division, then you can't do that cancellation. You need to have multiplication and division. All right, let's continue. From that, let's stop our numerator there and let's continue with the denominator. Here, we have 2 times 3 over 4. Exactly the same process. Just put an over 1, and now we can do our multiplication. 2 times 3 is 6. 1 times 4 is 4. But again, we can simplify this. We can simplify the 2 and the 4. If we simplify, we're going to have a 1, and down we're going to have a 2. We are not canceling like we did in here. We are simplifying. So now the solution will be 1 times 3 and 1 times 2. So 3 over 2, 3 halves. There you go. Now, let's continue working on the next exercise. What do we do first? Okay, so we have a parenthesis here, and that is the first process, right? Pendas, parenthesis first. We're going to have to do the multiplication here. How do we multiply these two? Well, in a straight line. 3 times -1 and 1 times 2. Let's do it here. X will be equal to 1 over 4 plus or minus the square root of 1 over 16 minus 3 times -1 is -3, and 1 times 2 is 2. And look at that. We have a minus and a negative. We can just cancel these two and make it so that these are positive. Did you see what I did? That completes the multiplication on top. Of course, down we have 3 over 2 as well. Let's continue working with our fraction errors. I don't have enough space down, so I'm going to continue my operations on top. Now, what is the thing we need to do? Okay, we need to solve the inside of the root first. We need to solve that addition first. And to solve that addition, we're going to have to amplify our fractionary. Sure, I'm sure you guys know how to multiply this in doing the cross and then the multiplying the denominators and all of that. But I like to amplify one of the fractions so that it has the same denominator. I'm going to multiply both up and down by a number so that now the denominator is 16. So by what number do I multiply the two so that it is 16? Please, guys, in the chat. Okay, we have one answer. What happened to the rest? There we go. 2 answers, 3 answers now. And I think, there we go. People are now writing. Beautiful. So I think everybody knows it. It is 8. We're going to multiply it by 8 down and by 8 on top. Remember, if you change the fractionary somehow, you need to change it both up and down so that it stays the same. All right. If I amplify this fraction, the fraction is now 24 over 16. And look at that. The fractions are now with the same denominator. Let me write the solution here. X will be equal to 1/4. That is the first part we have over here. We haven't touched that. Plus or minus the square root of 1 over 16 plus 24 over 16. Did you see? Again, in the denominator, 3 over 2. We haven't touched that at all. Let's continue with the operations. Here, how did you add these two fractions? Well, those two fractions have the same denominator, so we're going to leave the same denominator. Let me just write everything again. So 1 over 4 plus or minus the square root of. We're going to leave the denominator, 16, and add the denominators. So 1 and 24 is 25. There we go. The square root is going to end there. And in the denominator, we have 3 over 2. And now it comes the hard part. Man, what do we do now? We have a fraction inside the root. How do we find the root of a fraction? What do we do with this? Okay, guys, don't worry. Don't panic. Just like we did with the exponent, we had an exponent of a fraction, and we distributed the 2 on top and down. We can do that exactly here. We can do the square root of 25 and also the square root of 16. The solution, of course, just like in here, the solution was a fractionary. The solution of a fractionary to a power was a fractionary. In here, we will have a fractionary as well, but an easier fractionary. Let me show you. X is now going to be 1/4 plus or minus the square root of 25 over the square root of 16. Square root of 25 is 5, and the square root of 16 is 4. So we have plus or minus 5 over 4, and all of this over 3/2. Look at that. This is the moment where we split our equations. The moment where you solve the root is the moment where you split the equation. So we have one equation, which is positive. X equals 1 over 4 plus 5 over 4, and all of that over 3 over 2. A lot of overs in this exercise, right? But it is exactly the same process. This is one possibility, and now the other possibility. The other possibility will be with the negative value. So X will be 1 over 4 minus 5 over 4, and all of that over 3 over 2. Now, all we have to do is put on our thinking hats again, continue using our mathematical skills, and solve these operations. We have an addition of fractionaries and then a division. This is the way. X will be 1 over 4 plus 5 over 4. Look at that. How beautiful. We are still having the same denominators, just like we did in here. How lucky are we? We're just going to leave the denominator as 4. And on top of it, we're going to write 1 plus 5, which is 6. All of that over 3 over 2. Momentico en español, a veces se me pierden aquí. Nótese, muchachos, que a veces con ese poco de líneas de fraccionarios, tenemos 3 líneas de fraccionarios, 1, 2 y 3. Hay veces no sabemos qué va en dónde, qué es lo que es el numerador y qué es lo que es el denominador. Hay veces no sabemos eso. La forma en la que sabemos cuál es el fraccionario principal y cuáles son los fraccionarios que van arriba o abajo es dejando la línea del fraccionario principal más larguita. Mira, mira. Esta línea es un poquito más pequeña que esta. De esa manera sabemos precisamente que esta línea es la principal y es la que nos divide el fraccionario, lo que hay arriba y lo que hay abajo. ¿Listo? Aplíquenlo por favor en sus ejercicios. La línea del fraccionario, no escriban esto, mira. 6 dividido 4 sobre 3 dividido 2. Si hacen eso así, con el mismo tamaño, muy seguramente va a ser problemático saber cuál es el numerador y cuál es el denominador. ¿Será que es 6 sobre 4 tercios dividido 2? Para saber bien y tener ser un ejercicio organizado, dejemos el fraccionario principal un poquito más largo. All right, let's continue. In this case, exactly the process now, but now negative. But first, let's continue with this solution, all right? Now we have a fractionary divided by another fractionary. Remember, you're going to do these two multiplied and these two multiplied, right? 6 by 2 is 12, and you're going to put it on top, and 4 times 3 is another 12. Look at that. How lucky are we? The solution of the first solution is 1. 12 divided by 12 is 1. And what would be the solution of the second one? All right, let's see. X will be 1/4 minus 5/4. So we have fourth in the denominator, and on top of it, because they are the same denominator, they are 4 on both, so 4. 1 minus 5 is -4. -4. And down we have 3/2, right? Now we can do the exactly same process. We're going to multiply these two and these other two. The ones on the extremes and then the ones on the inside. From here, -4 times 2, that would be -8. And down in the denominator, we will have 4 times 3, which is 12. Okay, in this case, it was a fraction, but it wasn't a 1 like in here, but we can simplify this. If we simplify, we can divide by 4 and divide by 4 here. If we divide by 4, we're going to have -2. And if we divide by 4, we're going to have 3. So the solution, the second solution of x will be -2/3. Look at that. Two solutions for our equation. How did we know from the beginning we were going to have two solutions? Because the thing inside of the root is a positive number. Sure, it is a fractionary. So this is 1 point something, maybe, no, yeah, 1 point something. This is 1 point decimals. But it is positive. So it doesn't matter the magnitude. It doesn't matter what the number is. What matters is if it is positive, negative, or 0. This value was positive, so of course we have two solutions. One is 1, the other one is -2/3. Thank you guys for asking. This one is absolutely beautiful. An exercise that looks hard because of the fractionaries, but in all honesty, it is just long. It is not hard, right? Thank you guys for asking. We'll see in the next part of the video.